Howdy folks. All right, what we're going to do here is we are going to try and understand how to identify what is called the specific antiderivative of a function. Now, when you learned about indefinite integrals, for example, when we learned what is the indefinite integral of 3x squared dx, right? Or what is the indefinite integral of e to the x dx, okay? So you learned here with the power up rule that if we add 1 to the exponent, which now becomes 3, then we multiply by the reciprocal of that, which is 1/3. So we multiply by 1/3. 1/3 times 3 is 1. It just, the 3 cancels. And then 2 plus 1 is 3. And so our antiderivative is x to the 3rd power. And then we have to put on plus c, plus a constant, right? And then here, the antiderivative of e to the x, well, e to the x is the derivative of e to the x. So the antiderivative of e to the x, or the indefinite integral, is e to the x plus c. And so what I said when you learned this is that you would eventually learn how to identify what c is in certain circumstances. That's what we're going to do. That's what it means by specific antiderivative. In a specific antiderivative, you are identifying the actual value of c. But in order to do that, you have to be given information about this function. Basically, what has to happen is you have to be given an input and an output value for this function in order to solve for the specific antiderivative. Well, technically, you're first solving for c, and then you're putting c into the formula. So if we were to find, for example, here that c was equal to 14, then we would know that the specific antiderivative is x cubed plus 14. Okay, that's what it is. That's what we're going to do today. Now, the worksheet that you should be working with is this one right here. It says basic antiderivatives, number 6. It says specific antiderivative. Okay. Now, at the top of this worksheet, it says identifying a specific antiderivative means solving for the constant, the plus c, in the indefinite integral. And here's an example right here. Now, I'm not going to rob you of this example. You can just read it on your own. But basically, it says that f of x is a specific antiderivative of 2x, and f of 5 equals 32. So you're told that this graph is passing through the point 5, 32, and then you got to find out what f of x is. And so after you find, well, you can go through the example, but after you go through the antiderivative, you then plug in the 5 for x and the 32 for f of x, and you solve for c, and then just put it here. Okay, let's use both of these for just a second. We can use these as examples. Let's say, well, let me erase this. Let's say that the function f of x is a specific antiderivative of 3x squared. That means 3x squared is the rate of change. 3x squared is a function, and its antiderivative is the function f of x. So f of x is some function that we don't know yet, and were you to take the derivative of f of x, were you to identify f prime of x would be equal to 3x squared. Okay? So f of x is specific antiderivative of 3 of x, and f of 2 is equal to 9, let's say. I'm just sort of making this up right here. So, and f of 2 equals 9. All right? Well, the procedure is pretty simple here. The very first thing that you want to do, step 1, and I think I put this on the page, yeah, identify the indefinite integral. Identify the indefinite integral, okay? That means the indefinite integral of this thing. All right, well, the indefinite integral of 3x squared dx we just did is x cubed plus c. Okay, so we did that part. Step 2 says set it up as an equation and input the x value. Okay, so step 2, set up an equation with, and you're going to use both the x with the x value, and then you're going to set it equal to, with the x value, input and the integral, well, let's say with the x value input in the indefinite integral, and then equal to the output. That's a lot of words, but let me just show you the example. So I'm going to take this x cubed plus c, and in place of the x, I'm going to put the 2, because the 2, it says f of 2 equals 9. Okay? So f of 2 equals 9 means we have this coordinate 2 comma 9. So the x value is 2. So we're going to put a 2 in for the x, and then it's to the third power plus c. So this is our indefinite integral with 2 plugged in for x. Then we're going to set that whole thing equal to the output value 9, to the y value 9. Okay? All right. Then step 3, solve for c. Step 3, solve for c. Okay, well, we're going to solve for c. So 2 to the third power is 8. So 8 plus c equals 9. We're going to subtract 8 here, subtract 8 here, and we get c equals 1. Okay, so we now have our c value. And then step 4, write the antiderivative as a function of that for whatever function you're dealing with. Okay, write, well, let's say plug c into the indefinite integral. And then that final answer, when we plug c into the indefinite integral, we have a specific antiderivative. So f of x is a function, and it's a specific antiderivative. The antiderivative of 3x squared is x cubed, and we would put plus c, but now that c is equal to 1, we're going to put plus 1, and that's our final answer. So f of x is x cubed plus 1. And this is a specific antiderivative. This is very specific. There is no variable, there is no any constant, there is no plus a constant in here. And we can confirm that this is a specific antiderivative of 3x squared by taking the derivative of this. Well, the derivative, f prime of x, is 3x squared, and the constant goes to 0, and sure enough, there it is, 3x squared, and this is an antiderivative of 3x squared. So that's how we solve a specific antiderivative, and they can all be done this way. But let's do another example. I promised you we would do that e to the x example. All right, so let's say that g of x is a specific antiderivative of e to the x, and g of, I don't know, let's say that g of 1, now let's make it a little more interesting than that. Let's say that g of 3 equals 10. Let's say g of 3 equals 10. So that means this antiderivative, this specific antiderivative, passes through the point 310. Okay? And only one of these antiderivatives of e to the x passes through the point 310. Only one of them. Okay, so first thing we're going to do, let me do it in a different color here. Let's see here, we're going to identify the indefinite integral. Well, the indefinite integral of e to the x is e to the x plus c. Then it says set up an equation with the x value input into the integral and set it equal to the output. Okay, well, I'm going to plug 3, the x value, in for x here. So I'm going to have e to the third power plus c, and then I'm going to set that equal to the output, equals 10. And now solve for c. So in order to solve for c, I have to subtract e to the third power, subtract e to the third power, and now c is equal to 10 minus e to the third power. And I know what you're thinking, well, what's e to the third power? Well, ballpark, well, it's somewhere between, somewhere between about 9 and 27, okay, because e is close to 3. It's somewhere in there. I don't know what it is, but it's probably closer to 27, making it this probably a negative number. But here's the thing. If we don't have a calculator, we can't say for sure what it is. So here's what we're going to write. We're just going to plug c, this whole thing. We're going to put parentheses around it, and we're going to plug it in for c. And so g of x is equal to, go back to the antiderivative, e to the x power plus whatever c is. Well, c is 10 minus e to the third power. And so this is our final answer. Now let's say you have a calculator and you can find out what 10 minus e to the third is. That's fine too. All right, if we have a calculator, we'll do 10 minus e to the third power, which is about negative 10. It's negative 10.0855. All right, so negative 10.0855. Is that right? Yeah, there we go. So we could say that g of x is equal to e to the x power, and since this is negative, we'll put minus 0855, and this is our specific antiderivative. But personally, I like this one better. This one is more precise, leaving it as the 10 minus e to the third power. That's how you do a specific antiderivative. I think you may want one more example, because looking at this worksheet, you may be frustrated with maybe one of the trigonometric functions. Ooh, now that I look at this, I don't think you're able to do question number 12. You know what? No, I'm not going to do 12 right now, but skip question 12. I doubt you're able to do question 12 because it requires integration by substitution, and you probably have not yet learned integration by substitution. Well, if you have, then go for it. That means you also can't do question number 5. So skip 5 and skip 12. In that case, we're going to do one kind of like 5 and 12 right here, right now. But I'm not going to do it with integration by substitution. I'm just going to make it a simpler problem. Let's say that we have some situation. Let's call it h of x, I guess. So, all right. So we've got h of x is a specific antiderivative of, let's say it's specific antiderivative of sine of x. Okay? And let's say that, let's say that h of x passes through the point, let's say it passes through the point pi over 3. Oh, hang on. How about a whole coordinate there? Okay. Passes through the point pi over 3 and, I don't know, and 5. Just for fun. Okay. All right. And it passes through the point pi over 3 and 5. That means that when you plug pi over 3 into h of x, you get an output of 5. Okay. Well, first thing we're going to do is identify the indefinite integral. Well, the indefinite integral of sine of x with respect to x is, well, the antiderivative, sine of x is the derivative of negative cosine of x, right? So negative cosine of x plus c. So there's our indefinite integral. And it says set up an equation with the x value input into the integral. So we're going to take the x value, pi over 3, and plug it in for x. And then we're going to set it equal to 5. All right, so for step 2, we're going to do negative cosine of pi over 3 plus c equals 5. All right, well, so let's add cosine of pi over 3. I know some of y'all are dying for me to just go ahead and put a number in there, but we're going to do it this way. So we're going to add cosine of pi over 3, into both sides. We're going to cancel. And now c is equal to 5 plus cosine of pi over 3. And then pi over 3, cosine of pi over 3, if you think of your unit circle, in fact, pause right now. If you're not sure what it is, pause right now. Look up your unit circle, try and remember, or draw yourself a unit circle and try and remember. But cosine of pi over 3 is 1/2. Okay? So c is equal to 5 plus 1/2, which if you really wanted to, we could just call that 5.5. Okay? And so now now that we solved for c, we're just going to plug c into the original indefinite integral here, and we're going to say that h of x, the function h of x, is negative cosine of x plus 5.5. Okay? And this would work. You can check your work here. You can take your pi over 3 and plug it in. Cosine of pi over 3 is 1/2, but it's negative here. Negative 1/2 plus 5.5 equals 5, which is our output right there. Okay? That's how you identify the specific antiderivative of a function.
I mean, they don't care about the sleep. Not people in school. I'm talking about work though. That's my stuff at work. We don't have to get on business. But then, if you staying in, Georgia, bro.